The uphill rail. Two cones that are joined together that run up the slope. Looking at the diagram, although the cone is travelling up the rail, its middle point or centre of gravity is going down. As the two rails get higher, they get wider apart, so the cones can run down. I want to know, could we extend the rails a bit further and see if it could keep going? Could it get back up to the height that it started with? Well, not according to the laws of conservation of energy, but how close could we get? Two 3D printed cones, one steel ball to give it a bit more weight. Let's put it together. The line in red shows where the cone stops, and the momentum keeps the axle running, so we keep going up the hill. The height of the cone axle at the lowest part of the rail is 65 millimeters, and the height at the highest and widest part of the rail is 55 millimeters, so we're 10 millimeters away from the height we started with. As the cone wheel rolls back down the slope, it will eventually settle at the transition point between the cone and the axle. That's just a screw marking that position. Okay, we need more rail. And it needs to stop getting wider and run parallel. So this should do. I'll use the laser level to mark the mid position of the axle. At the high end of the slope, the same laser line will show us the position we would need to reach to get to the same 65mm height. Mind you, if the cone manages to get there on its own, we'll have broken the first law of thermodynamics and all physics teachers will implode. But, that's okay. So how close can we get it? That's 59mm height. That's just 6mm away. Okay, I want to try something with the weight of this. Let's try removing the ball and making the whole thing a lot lighter. The ball is 266 grams. That's 58 grams compared to the 324 grams we started with. Okay, that's gone slightly further. That's a height of 60 millimeters. That's just 5 millimeters away. I thought a heavier cone would have travelled further. I'll try something a bit bigger. Okay, that's 504 grams. That should give it a bit more momentum. Trouble is, I need to raise the rail now and reset everything. Didn't think that one through. That's 108 millimeters height. That height measures 102.2. That's 5.8 millimeters away, so not as good as the smaller, lighter cone. It has more momentum running down the cone, but the extra mass makes it harder to run further up the slope. At least, I think that's what's happening. So, back to the original rail setup. Yep, minus 5 millimeters away from our starting height is still our best result. I've changed the shape of the cone. It now starts at 30 degrees and then transitions to the 45-degree slope. The idea is that it starts off slower, but then accelerates as it goes down. That measures 59.5 millimeters. So again, 5.5 millimeters away from our target. So working on the theory that the lighter cone went further, I'm going to try a super light version, only 1 millimeter thick and weighing just 13 grams. That's 58 millimeters height. That's getting worse. That's 7 millimeters away from our starting height. I'm going to make a super light version of the 45-degree cone, since that's been the best result so far. And that's 11 grams weight. Definitely rolls better. That height is 57.6, which means 7.4 millimeters away from the height we started at. Disappointing. So it looks like there's a sweet spot of weight. Too much and it reduces how much we can come back up the hill. Too little weight and it just doesn't have enough momentum. Either way, we'll always lose energy. So like a pendulum, we'll never get back up to our starting height unless we put more energy in. So it looks like that's it. On the other hand, what would happen if I added some wheels? Yeah, this is not going to work very well. The rails are going to have to be a lot wider. I think I'll leave this for another time. If you've enjoyed this, please give me a like and subscribe. Thanks for watching.